All right, let's just dive right into this explainer. Today, we're completely shifting our mindset. We need to stop treating AI like some conversational chatbot and start looking at it as an engine. Specifically, we're going to learn how to engineer deterministic, battle-tested agentic pipelines that actually do the heavy lifting exactly the way you want it done. And look, none of what we're covering today is theoretical. This whole explainer is pulled straight from the Zenva team's hard-won experience. They've essentially distilled a full year of actual, in-the-trenches production mistakes. We're talking real, frustrating, costly slip-ups into 101 concrete rules for reliable automation. It is literally a survival guide for getting serious work out of AI. So, the core philosophy driving everything we're about to discuss boils down to this. Claude Code rewards habits more than it rewards features. Reliable AI output? It isn't about crossing your fingers and hoping the next model update drops a magical workflow fix. No way. It's all about strict constraints, well-defined memory hierarchies, and building automated safety nets. To get there, we're building a pyramid of agentic reliability. We'll be hitting 1. Setting the agentic foundation, 2. Planning and verification levers, 3. Automating with custom skills, 4. Guardrails and deterministic hooks, and finally, 5. Enforcing truth and quality. Let's get to it. Starting with Section 1, Setting the Agentic Foundation. Your project setup here absolutely determines your long-term success. Now, the crucial point here is actually subtraction. See that number? 1,000. That is your absolute hard limit. You have got to keep your project's CLAUDE.md file strictly under 1,000 token limit. Why? Well, because bloated instruction files cause the agent to just lose your actual critical instructions in the noise. It's like trying to find a needle in a haystack. Every time you're tempted to add a new rule, you have to ask yourself, if I remove this, would it cause a mistake I've actually seen happen? If not, cut it. So, to manage those tokens without losing your mind, you rely on a 3-tier memory hierarchy. We've got a global file for cross-project habits, a project file for team conventions, and a personal file for individual overrides. The real genius here is that you completely avoid duplicating rules. You assign every single rule to exactly one specific level. This stops you from burning through the AI's precious attention budget on redundant instructions. Moving right along to Section 2, Planning and Verification Levers. All right, think about the difference between a lazy, vague prompt like add authentication versus a strict constraint like use existing user model and store in Redis. The strict prompt acts as a literal guardrail. By explicitly naming what to use and, just as importantly, what not to change, the model has absolutely zero room to invent things. You give it nothing to hallucinate. And hands down, the best verification lever for this is the writer/reviewer pattern. You basically use 2 completely separate AI sessions. Session A does the writing, Session B reviews it. Because Session B has completely fresh context, it catches all those hidden assumptions and biases that the first session quietly smuggled in. It's an absolute game changer for amplifying quality. Next up, Section 3, Automating with Custom Skills. So, what happens when you find yourself writing the exact same long, strict prompt 3 times in a row? Well, you turn it into a custom multi-phase pipeline skill. To avoid total AI disasters, you can't just let an agent run off and do 20 things blindly. Complex skills have to be designed as idempotent pipelines, meaning they can be run over and over safely without causing weird side effects. You number the phases, you define crystal clear inputs, and most importantly, you drop explicit gates before any permanent action is taken. The absolutely critical point here is enforcing those human approval gates with explicit stop markers. Consider a rule like, do not call the scheduling tool before the user confirms, no matter how clear the inputs were. If you miss this gate, the AI might just assume a smooth run means implicit approval. And suddenly, boom, an unapproved video, a messy draft, or some embarrassing tweet is live for the world to see. Which brings us to Section 4, Guardrails and Deterministic Hooks. Let's dive into the climax of control here. We're shifting away from probabilistic prompts to hard deterministic safety nets. You see, prompts, they're often treated as mere suggestions by an LLM. Hooks, on the other hand, are guarantees. They execute mechanically at very specific lifecycle events to enforce rules, block actions, or handle formatting. They don't care about the LLM's judgment. Hooks guarantee execution, making them your ultimate weapon for blocking irreversible mistakes. Now, the timing of these hooks gives us the rule of the tool. You absolutely must catch bad behavior in the pre-tool use hook by returning an exit code of 2. That acts as a hard stop, instantly halting the process. Why? Because by the time the post-tool use hook fires, the tool is already run. Post-tool is for things like auto-formatting. Pre-tool is for hardcore protection. Listen, you simply cannot trust an LLM's judgment to remember not to wipe your entire database. You've got to block highly destructive bash patterns, stuff like a force push or a hard reset, using that pre-tool use hook. When the code matches the regex for those dangerous commands, the hook returns exit code 2, blocks the action cold, and forces the AI to rethink its life choices. Finally, we hit Section 5, enforcing truth and quality. For this final layer, dealing with the outside world, you have to be incredibly literal. Asking an AI to just sound natural? Yeah, that doesn't work. You have to explicitly ban those robotic writing tics by name. If you never want to read the words delve, embark, or furthermore ever again, you literally have to put them on a hard banned list. And to absolutely stamp out invented facts or hallucinations, you've got to give the AI a grounded reality. What you do is provide a local markdown mirror of external documentation, your facts directory. Then you demand that every single claim, definition, or statistic traces directly back to it. Sure, it restricts the agent's scope, but it makes your output rock solid, defensible, and actually accurate. Ultimately, every task lifecycle has to end in verifiable reality. From iterating the plan, to verifying the code, to passing that human approval gate, it all culminates in a deliverable URL. Never, ever just accept the AI saying it's done. Outputting the exact URL to the pull request, the live page, or the video, that is the ultimate verifiable unit of work. So, as you apply all these constraints, the strict hooks, the writer/reviewer patterns, the local fact mirrors, don't let automation lull you into switching off your brain. You have to actively engineer your guardrails. I want to leave you with this. Look at how you work today. Are you just managing a chatty AI assistant, or are you actually ready to program a truly autonomous system?